Alright, so welcome back to OneClass and our live stream for today. My name is Joey. I'm going to be your math and chemistry teacher for the session. Specifically, we're going to focus more on the math questions today. So before we get started, again, just a little bit about OneClass. If you're tuning in for the first time, thank you for watching. A little bit about OneClass. What we do is we provide online solutions and online videos and tutorials and lessons free of charge on our YouTube website at youtube.com/OneClass. And what we do is we post and we verify solutions as OneClass teachers. So all we do is we go through a series of questions. We look at the solutions and we walk through it together. So we prove that the solution is correct or incorrect, and that way we can improve on are solutions that are frequently asked questions sent in by you folks at home. So if you're a student or you're you're a student and you're learning about these subjects specifically in secondary school math and chemistry, and you have trouble answering questions, feel free to submit your questions, and we'll get to them as soon as possible, and then we can post videos like this in order for us to describe our thinking and to teach you the concept behind the question. So that's kind of our goal here for today. Again, I'm going to be streaming for about 2 hours a day from this block to 11, so 10 a.m. to 11, and from 12 to 1. So for this first block, I'm going to focus more on pre-algebra, geometry, and algebra 1. And the second block, we can move on to algebra 2 and pre-calculus questions. So that's how I'm going to split this today up into 2 sections. And yeah, hopefully we'll get to go through 10 questions together, and we can answer those questions as we move along. So without further ado, let's get started on today's problems. All right, so we have this question here. It says here, this question 1 states that if HLI is similar to if triangle HLI is similar to triangle JLK by the SSS, or the side-side-side similarity theorem, then HL over JL equals IL over KL is equal to what ratio? So let me draw this out for you. Let me rewrite the question as well. So let's look at this question here. So if triangle HLI is similar to JKL, triangle JKL, by SSS theorem, so this is by SSS theorem, is by side-side-side similarity theorem. So this ratio, let me see, by SSS theorem, then HL over JL is equal to IL over KL is equal to what ratio? So let me draw out the two triangles for you. And I think they drew it out as well. And I'll show you how they drew it out. So I'm going to do this in blue. So I have a triangle like this, and a triangle like this. This is K, J, L, and this is L, I, and H. Okay, so you have here your triangle. And it's here, so let me denote this in red. It says HL, so that's this point to this point, from here to here, is similar to JL, or it's proportional, right? It's proportional to JL, which is great. And IL is from here to here, is similar to KL. So what other ratio can we write here by SSS theorem to prove that these two triangles are similar? So let me give you a minute to think about this question. We might have to define SSS theorem for us to figure this out. But if you know it, again, if you're here in the chat, let me know by waving hi or just answering the question itself. But let me know what your thoughts are on this question. So how do we use SSS theorem? Or first of all, what is SSS theorem? Second of all, how do we use this theorem to write down another ratio to prove that these two triangles, so HLI and JKL, are indeed similar? Sorry, this is JLK. The order kind of bad. There we go. So let's take a minute to think about this problem here. So what we have is we have a SSS theorem, right? And by SSS theorem, that states that two triangles are similar. So let me write down the theorem here. So it states that two triangles, this is my shorthand from triangles, are similar if all three basically if all three pairs of sides are equal in proportion. So let me look. All three pairs of sides are proportional. And when we talk about proportional, it's simply this fraction here, right? HL over JL, right? So we need all three sides. Sorry, I didn't like how I wrote that. Proportional. So basically we need for Sss theorem to be true, we need all three sides of the triangle to be proportional. Three pairs of sides proportional. So if I have here HL, which is this length here, over JL, which is this length here, equals IL, which is this length here, and KL, which is this length here, my last missing side is obviously these two sides, right? These two sides here, they have to be proportional, which means in this case here, I can write my answer as I need this side here is equal to this side in proportion, right? It's proportional to this side. So I can say that HI over JK is also proportional for triangle HLI and triangle JLK to be similar through side theorem. Remember, so this here is our answer. So this here is our answer here. This is HI over JK. So let's look at this answer here. It says two triangles are to be similar if their corresponding sides are proportional and the corresponding angles are equal. That is, their corresponding sides are in the same ratio. So this is the ratio, right? HL over JL or whatever. Because I have this triangle, this length here and this length here are proportional in size, right? So since we have triangle HLI similar to JLK, therefore this implies that angle H equals angle J, angle L equals angle L, and angle I equals angle K. So they actually even broke it down even further, and they even talked about angles, right? So they said that angle J here, angle J is equal to angle H, angle L is equal to angle L, angle K is equal to angle I. So therefore, they wrote this here, right? And because this here equals HL over JL equals LIL over KL, therefore it also equals HI over JK, which is exactly what I wrote here. So they actually proved this even further with using angles, because remember, if you have this two sides that are similar in length, they also equal to angle, right? So in terms of if two sides are proportional to each other, then you will also get a same angle between those things. So between those two sides. So this here is a great solution and analysis. All right, so that one's good. Okay, sweet. So let's look at number 2. So 2 states that how many lines of symmetry does a parallelogram have? So how many lines, sorry, not sides, lines of symmetry does a parallelogram have? Okay, so take a moment to think about this question as well. So when we're talking about a parallelogram, let me draw this out, and they draw it out here as well. So let me draw out a parallelogram. All right, good sketch of that. So it says how many lines of symmetry does a parallelogram have? So think about this problem again. Again, the solution is already shown for us, but think about what does it mean when we talk about lines of symmetry? Well, how do we define a line of symmetry? And this is a geometry question. So again, lines of symmetry. So remember, a line of symmetry is that if you kind of cut the shape in half, both sides have the kind of exact resemblance to each other. So both sides are kind of equal to each other. So you can think of it as like a circle. In the shape of a circle, let me draw. I can use my circle tool here. In the shape of a circle, a perfect circle, if I split if I did a line of symmetry right down the middle, sorry about that. If I do a line of symmetry right down the middle, I have it's gonna be the both sides are going to be exactly the same, right? So I have this side here, the left side here, the left side here is going to be equal to this right side here, right? So it's exactly the same if that's considered a line of symmetry. If I can divide the shape into two, with both sides being symmetrical of each other, right? So, okay, if I did the exact same thing with a parallelogram, and I cut this in half here, you're gonna realize that both sides in this case, I do not have a line of symmetry, because if you look at this shape here, and I'll do the left side in blue to show you. So I'm gonna have this shape here, which is now a trapezoid, and then I have another shape here, which is kind of another trapezoid here. So in this case, it's not a symmetrical line, because I can't. If I divide this in half, I get two shapes here that are not symmetrical with each other. So let's see what they wrote here. So again, here it says the line of symmetry shape separates two symmetrical shapes. In the case of a parallelogram, no line of symmetry can be found. They sketched a parallelogram. Now it can be observed from the figure of the parallelogram that any line cannot divide the parallelogram into two symmetrical shapes. Therefore, no line of symmetry. So this solution here would be correct, because they simply just use logic to kind of to figure out this kind of problem here. If I wanted this shape to be this shape to be symmetrical, I would have to bisect this parallelogram. Right? I would have to go from here to here. Oh, whoops! What did I do? From here to sorry. From here to here, and from here to here, if I want, or from here to here, and this would split the shape in half. But this here is not a line of symmetry. Remember, I have to go right down the middle to get to be kind of considered a line of symmetry here. So in this case, I don't have it. So in this case, no lines of symmetry. No lines of symmetry. Sweet. So this here is a great solution. Great solution. And logic. Okay. Let's look at number 3. Number 3 states that how many cups are equivalent to 1 point? How many cups are equivalent to 1 pint? So let's look at this problem here. How many cups are equivalent to a pint? So this is what we're working with here is the imperial system, which most of our friends in the United States work with. So this is the imperial system. So how many cups are equivalent to a pint? So if you remember our imperial system, our biggest imperial system here would be 1 gallon, right? We have 1 gallon here. 1 gallon would equal 4 quarts, right? 4 quarts. And then how much is 1 quart equivalent to? So 1 quart is also equivalent to 2 pints. Let me just look. What quart? Quart 2. Yes, 1 quart equals 2 pints here, and then 1 pint equals 2 cups. And then that's basically all you kind of need to do, right? You could do 1 cup equals to fluid ounces, and this would equal 8 fluid ounces. Here, so 1 cup equals 8 fluid ounces. Okay, so you have this is our kind of conversion chart here. It's asking how many cups are equivalent to 1 pint, right? So 1 pint would have to be 2 cups, right? Like by definition, this here is our answer, right? 1 pint equals 2 cups. And basically with the imperial system, what you have to do is you kind of have to just memorize these kind of conversions here. So 1 gallon equals 4 quarts, 1 quart equals 2 pints, 1 pint equals 2 cups, and 1 cup equals 8 fluid ounces, right? And we have to be very, very comfortable when we're switching from gallons to quarts, or quarts to pints, pints to cups, or cups to fluid ounces, right? And then what we can do is we can actually jump, right? You can actually do cups to pints, quarts to fluid ounces, gallons to fluid ounces, and all that stuff, right? So it depends on what we're doing here. Again, you can think of this as we are multiplying as we go down and dividing as we go up. So let me write, as we go down the chart, we multiply. Let me just multiply. As we go up, we divide. That's kind of how we use the imperial system here. So again, 1 pint equals 2 cups is our answer. They got that same thing here. There are 2 cups to 1 pint, and then they did the exact same conversion like so. Okay, yeah, this is a good solution. Great solution. And step by step. Sweet. So this is number 3. Number 4. I'm pretty fast today. It's good. So number 4, how many quarts equals 8 cups? So exactly kind of the same thing as our question before. So I'm going to use the exact same chart, so I don't have to redraw it. So how many quarts equals 8 cups? So take a moment to think about this question. And we're going to solve it together. So how many quarts equals 8 cups? And I'm going to go back to our conversion chart here to kind of help you out here. How many quarts equals 8 cups? So we would have to kind of go from cups to pints first, and then from pints to quarts. Right? Remember, when we're going up, we want to divide, right? So that's how we're going to convert this first. How many quarts equals 8 cups? Remember, we're still in the imperial system. We're still working with these measurements as well. So take a moment to think about this, and then we will reconvene and talk about the answer here. So let's take a moment to answer this problem here. We have 1 pint equals 8. We have how many quarts equals 8 cups, right? So let's start with this measurement, cups here. Let me see if I can, yeah, let me do that. So I have 8 cups here. So in 1 pint, I have 2 cups, right? Which means I have to convert my cups into pints, right? So I'm going to have to say 1 pint would equal 2 cups, right? There's 1 pint. There's 2 cups per pint, right? You can say like that as well. So we are multiplying by half, or you can say divide by 2. Remember, as I'm going up the measurement here, I'm dividing by 2, right? And again, I'm using this concept of dimensional analysis, so I can make sure my my units cross out here. And then I have to convert to quarts, right? So, but how many quarts are in a pint? As you can see, so how many pints are in a quart? I have 1 quart equals 2 pints, right? Which means I'm going to have to put 1 quart. There's 2 pints in a quart, right? 2 pints in a quart equals. And now you can see that my units cancel out, right? I have cups here cancels out, cups cancels out, cups cancels out. pints cancel out and pints cancel out, right? So all I'm left with here is quarts at the top, which is what I want, right? That's my unit. That's my unit of interest here, right? Quarts. So let's do the math here. It says is 8 times 2, or 8 times half here is 4. 4 times another half would equal to 2, right? So I have 2 quarts is my answer here, which means I can write a statement that says 2 quarts, or is it right? Therefore, 2 quarts equals, or write equals 8 cups, and this here is my answer, right? And I can use a box and boxes in, box, and therefore 2 quarts equals 8 cups, and here is my answer. Again, here this concept is the concept of dimensional analysis. So I'm making sure my units here are canceled out, and I get the correct unit in my answer. Dimensional analysis. Okay, so let's see here. They did the chart here, like I said before, right? They did kind of this chart here, but they did it in a table more so, and then they multiply as you go down, divide as you go up. That's good. And then what they did was they did kind of the same thing. So 1 cup equals 1/4 of a quart. So 8 cups would mean 8 times 1 quart, right? So you can say you did it this step first. So half times half is a quarter, and then 1 quarter times 8 here equals 2. So therefore, there are 2 quarts equals 8 cups. So this here is the correct answer and great solution. Correct answer and analysis. Sorry, not solution. It's correct solution and analysis. Solution here is correct. Oh, nice. We're actually on time today. It's 10:22, and one more question 5 is pretty good. Moving at a decent pace here. Might even finish early. So first. Okay. So it says here, which similarity statement can you write relating the 3 triangles in the diagram? Okay. So I'm going to draw this triangle. Actually, I'll write the question here first. Which can you write relating the 3 triangles in the diagram? Okay, so this is which similarity statement can you write relating the 3 triangles diagram? I'm going to draw up my triangle here. I have something down the middle, right? Like so, and this here is a right angle. And then this is a V. This is a W. On this here is also a right angle. This is a T. This is a U. Okay. So it says, what similarity statement can you write relating these 3 triangles? Again, take a moment to think about this problem here. Maybe I'll redraw. Maybe I'll use blue to signify my letters here. So so it's not as confusing. So it's 2, T, U, V, and W. And I have a right angle between the bisecting point here, and then a right angle within these 2 triangles. So what similarity statement can you write relating the 3 triangles in the diagram? So what I would do is, because we're not given any side lengths, I would focus here on the angles itself. So focus on the angles here. Let's take a moment to think about this problem. Or maybe I'm going to write down the logic here. Since no side lengths are given, focus on angles provided. So since no side lengths are given, we would focus on the angles provided, right? So take a moment to think about this problem again, and then we'll take up this answer as a group. All right. So how we would solve this problem would be, since no side lengths are given, focus on the angles provided, right? So let's look at the angles here. I'm going to do this in red. So we have a 90-degree angle between these two triangles, right? If you think about this triangle, there's triangle 1 here, or triangle TUW, and also triangle UV, or UWV, right? So let me do UVW. Okay, so you can think of this right angle triangle here as 90 degrees, right? And you can think of this angle, it distributes evenly to two 45 degrees, right? So this angle here is 90 degrees. It's a right angle. We're going to divide it by 2, right? Because it's split this angle. I'm going to split the two triangles evenly, right? So I have one angle here and one angle here as well. Here as well, which means it's 90 degrees divided by 2. So it's 45 degrees for this angle here. So this angle is 45. This is also a 45 here, right? So this here is, here is my angle. And again, here I have a right angle at U, right? So which means this is also a 90 degrees angle, right? 90-degree angle. So therefore, what I can do is I can actually solve for my missing length, my angle T here, right? So I'm gonna solve for my angle T. So I can say that angle T equals, I would equal the sum of the interior angles of a triangle, which is 180 degrees, minus, I'm going to have 90 degrees here, minus 45 degrees here, right? Which means the answer should be 45 degrees. 180 minus 90 is 90, 90 minus 45 is 45, which means this angle here is 45, right? I'll do that in red. This here is 45 degrees, right? Oh, sorry. This here is a 45 degree angle, right? So now I have 3 of my angles that are I solved for 3 of my angles, right? Which is awesome. So now what kind of similarity theorem could I use to say that to relate these 3 triangles in the diagram here? Remember, I have 3 triangles, right? I have one here, and one as a big total, right? Oh, so this is a multiple choice question. I lied. Oh, I thought it wasn't a multiple choice. Sorry. Okay, so maybe I'll readjust my thinking here. So let's look at the first one here. It says T. Actually, let me do this in blue. From A. So from A here, it says that triangle TWV is similar to triangle WUV, which is similar to triangle UVT. Okay, so let's look at this one here. So it says here TWV. So TWV, so this big triangle here, is congruent to WUV, which is similar to UWT. So that's here is my first one here. It's this big triangle is similar to this one here, and it's similar to this one here. So that's here is my first triangle here. That's my first statement here. And let's look at B here. B here would be triangle UVW is similar to triangle WUT, which is similar to WVT. So this is UVW is similar to WUT, which is similar to WVT. So in this case, it's just the same. It's the same triangle, but they're using it in a different order, right? And they're writing these triangles in a different order here. And then finally, or let me write this down. I have C, which is triangle WUT, similar to VUW, which is similar to triangle UWT, right? So WUT is similar to VUW, which is similar to UWT. So this C here is incorrect here because I'm restating my my triangles, right? So if WUT is this first triangle here, VUW is my second triangle here, and UWT is again my first triangle here. So in this case, C is actually the incorrect answer here. So I can cross that out because it's stating the same triangle twice. I have D is triangle UVW is similar to triangle UWT, which is similar to triangle WVT. So this is, again, UVW is this top triangle here, UWT is this bottom triangle here, and WVT is the big triangle here. So A, B, and D all incorporate these three triangles. So let's look at the solution here. It says option D is the correct answer. So it says here, use the theorem if the perpendicular drawn from the right angle of a triangle of the hypotenuse to the hypotenuse, then the triangles on both sides are similar to each other and similar to the whole triangle. So it says if the triangle drawn from the right angle of a triangle to the hypotenuse, then the triangles on both sides are similar, right? So if I'm drawing a hypotenuse, I'm drawing this here. A perpendicular is drawn from this right angle here, from this right angle at W, to the triangle, to the hypotenuse. Then the triangles on both sides are similar and similar to the whole triangle. So this here, this line defines my the perpendicular here. So let's look at their explanation and let's see if it's good. So it's saying that A here, since angle U is 90, angle U here is 90 in VUW, but the corresponding W in UWT, corresponding W here in UWT is not equal to 90. So they're taking these two angles and they're saying angle W here is not angle, it's 45 actually instead of 90. So it's incorrect, which is great. Incorrect since U90 here in UVW. So in here, UVW, but the corresponding W is not equal to 90. Right? Again, this here again is 45. C, we already talked about this logic here. It's talking about the same triangle, and D here because it's corresponding, right? So let me look at D here, and D states that UVW. So again, UVW is correspondent to UWT, which is correspondent to WVT, right? So we have the right angle here. We have the right angle here, and this here bisects, or the perpendicular between here is also 90 degrees, right? I have angle W, the big W here is the entire triangle here is 90 degrees. This is also 90 degrees, and this is also 90 degrees. So option D here is correct. So this here is the corresponding angles are equal, therefore by AAA theorem. So we're using, actually this is AAA theorem, and the solution didn't state this. So it's because it's asked, the question asked what theorem are we using, right? Or what similar statement can you write? So actually it's by AA theorem, so we can say that D is correct. So good solution and logic. We are using a theorem to we're using so we're using if two of the angles are the same, if two of the angles are the same, the third angle is the same, and triangle is similar, right? So to prove similarity. So the solution here is correct. Sweet. I did not see the multiple choice. Sorry, guys. Okay, so this is question 5. Let's look at question 6. So how many sides does a regular nonagon have? So this actually goes back to my previous video of shapes again. So let me have to rewrite this. So how many sides does a regular nonagon have? So when we talk about polygons, again, we have these prefixes, right? So remember, so polygons are basically shapes with are closed shapes, right? With their sides have to be more than 3, right? So if I have a 3-sided shape, or have a triangle, right? And I did kind of this list back in my previous video 4 sides would be a quadrilateral. 5 sides is obviously a pentagon or pentagon. 6 here would be a hexagon. 7 is a heptagon. 8 is an octagon. And finally, 9 here is a nonagon, right? And then if I want 10 is a decagon. So again, how many sides does a regular nonagon have? This here would equal 9, right? 9, there's 9 sides to a nonagon. And again, these prefixes help me a lot, right? Non here is a prefix of 9, right? Tri here is 3, quad here is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca here is 10, right? So these prefixes tell us that there's how many sides in the regular nonagon here. And when we talk about regular nonagon, it means that, like, what does regular mean? Regular means that all sides have same length. So all 9 sides have the same length. If all sides have different lengths, it would be a irregular nonagon here. So this, in case, how many sides does a regular nonagon have? It has 9 equal sides. So the answer here would be nonagon has 9 equal sides. So the solution here, again, they kind of did the same thing as me, where I kind of did a little graph here, and they broke it down to prefixes, which is good. Answer nonagon has 9 sides here. So the solution here is correct. And again, regular nonagon just means that it's a nonagon with all sides are equal to each other, so they get equal in length to each other. Great solution and analysis. So this is number 6, and this question here is correct. Let's look at 7. So it says, which segment of the hypotenuse is adjacent to? This is kind of like my triangle from before, right? Segment AB, right? So it says which segment of the hypotenuse is adjacent to segment AB, right? Segment AB. So let me redraw the triangle for you again. Maybe I'll draw it from a top-down approach. So maybe I'll draw it like this. Maybe it might be you folks are easier to see here. So again, I have this here. This is a right angle. It might not be easier for you. Sorry, I'll redraw it like so. It's very hard to draw a triangle. Okay. And then I have this line here bisects it. And this here is a right angle. Even though it doesn't look like a right angle, that's totally fine. This here is a right angle as well. Okay. And then I have, this is segment A, B, right? This here is D, this here is C. Okay. So it says here, segment AB is adjacent to, which segment of the hypotenuse is adjacent to AB, right? So I'm looking at this length here. And again, we know that these two triangles are indeed similar, right? So it's asking us, well, the side length now. So if we know they're similar in length, I can say that AB here is this length, this blue length. Which side of the triangle would it be adjacent to? So it says here, I have options A or D. So AD would not be the correct answer because it's in the same triangle, right? Again, it's in this top triangle here. So AD, here's the wrong answer. What about CD? CD here is this side here, but this side is equivalent to this side, right? So that's definitely not correct here. And so CD is also incorrect. I have BC, and then I have BD, right? So again, BD would be the exact same exact same line segment for both triangles here. So this here is also incorrect because this segment is part of this same triangle here. So in this case, the last answer I have here is BC, and BC here is the correct answer. Because what I'm doing is I have this line segment here is adjacent. It's adjacent to this line segment over here. So let's look at the answer here. It says option A is the correct answer. Oh shoot, what did I do wrong? Oh, it says adjacent, not equal to. Oh, my bad. Sorry, I read the question wrong. I thought it was equal to, because I assumed that AB here is this triangle here is adjacent to this triangle. Sorry, not adjacent, it's equal to. I thought the question asked which segment of the hypotenuse is adjacent to. Oh, this makes, okay, so this is a lot easier for this problem here. So again, AB here is simply just adjacent to AD, right? Adjacent just means across from. So across from this side is this side here, right? So that's all they're asking. I thought they were asking me to prove that the two sides are equal to each other. So that's my fault. That I read the question wrong. The answer here is AD because I have again, AB here is across from this side here, right? So again, they're adjacent. Across means adjacent. So this here, AD is the correct answer. So let's see the explanation here. The part of a line has two endpoints. Okay, down the given figure, we have three right angle triangles, angle ABC, BDC, and BDA. Hypotenuse of AC, BC, and AB are respective. So AB here, CB here, and then AB, right? Now adjacent sides are AB, are AD, and BC. Yeah. But BC is not the segment of any hypotenuse side. Or BC here is not adjacent to any hypotenuse, hence AD is the only line segment that's adjacent to AB, right? CD is not adjacent, it's actually, CD is not, because it's not even in the triangle. BC here is the exact same side, sorry, not adjacent to, and BD here is the opposite side, not the adjacent side. So again, this answer is AD. So great solution. And step by step. So that was my fault, guys. I thought that I was asking for which segment of the hypotenuse is equal to AB, not adjacent to. My fault here. Let's look at number 8. It says a hallway measuring, let me write this down, a hallway measuring 90 feet by 7 feet requires half a fluid ounce of cleaning solution per square foot. How much cleaning solution? How much cleaning solution to clean the hallway? I'll just write that. Okay, so how would we solve this geometric problem? So I'm going to draw a diagram for you first before doing the math. So it says here a hallway, so whoops, I want the rectangle. So I'm assuming a hallway kind of looks like this, right? A hallway like this. I filled my dimensions. I measured by 90 feet by 7 feet, right? So 90 feet would obviously be the length. And then this here is 7 feet, right? So I have two my dimensions here. It requires half a fluid ounce per square foot. This here is the giveaway here. Per square feet, it means I have to figure out, when we talk about square foot, this is the area, right? So how much cleaning solution is needed to clean the hallway? So our first step here is step 1. Step 1 is to figure out the area of the hallway. So figure out, so let's see, step 1. So I need the area of hallway. So again, I have area of a rectangle equals the length times the width, right? That's standard, this standard formula here. The area equals, again, the length here is 90 feet times 7 feet, right? Times 7 feet here. Therefore, the area would equal 90 times 7 is 630 square feet. So that's the area of my hallway here. And so that's step 1. And now finally, step 2. I'll do this in blue. Step 2 would be to calculate my cleaning solution, right? So I need a volume, right? This is a volume. So calculate volume. So we know from the solution that it says it requires half a fluid ounce of cleaning solution per square foot. So I can say that I need half a fluid ounce per square foot, right? So half fluid ounce per square foot, right? So I have that, and I'm going to multiply it by, I have 630 feet, right? Or square feet, right? So I have 630 square foot. Sorry. 600 square foot. So that would equal, again, here, my units cancel out, right? My units cancel out square foot and square foot. Therefore, I have 1/2 times 630, which will give me 315 fluid ounces. 315 fluid ounces would be my answer for this problem here. I need 315 ounces of cleaning solution for me to clean my hallway here. So let's look at the solution here. It says area of hallway is a rectangle, good, calculated by area equals 90 times 7, which is 630 square feet. Half a fluid ounce required to clean 1 square foot. So you can say that 630 feet is cleaned using 315, which is this solution here. Half times 630 gives me 315. So that's good. Again, I'm using the concept of dimensional analysis to solve for my units to make sure that my units here are clean, right? At half a fluid solution, half a fluid ounce per square foot. So this solution here is also correct. So great solution analysis. Solution here is correct. So this brings us to this question 9. Oh, we can probably finish all 10 questions today, which is awesome. Question 9 here states which figure shows a line of reflectional symmetry for the letter T. So which figure shows a line of reflectional symmetry for the letter T. So when we talk about, so again, what is this topic of reflectional symmetry? So again, take a moment to think about this problem here. What's the difference between, these are all, let me scroll into the options here. So I have A here, this is a T, B here's a T, C here's also T, and D here's also T. But which of these show a reflectional symmetry? What does that, so what does the first reflectional symmetry mean? And how do we find that? How do we figure that out? So let's look at A here. So A here, I have a line down the middle, so it splits it up to these two parts, right? It splits the line splits it up to. Let me try if I can draw this out properly. So this is for A. It splits it up to kind of this thing here. I have one side like this, and then the other side like so, right? And then these two parts. So if I split it down the middle, I have something like this, right? Let me erase this here. And you can see, are these two parts equal to each other? In this case, yes, right? Therefore, because what I can do is I can translate this. I can reflect this onto. You can think of reflecting along the y-axis here, and I get the exact same. I can flip it onto its side and get the exact same shape, which means A here is a correct answer. So this here is correct. let's look at the other solutions here. I have B here. So B means if I cut that shape like so, like horizontally, the shapes I get are this shape here, one here, and then I get basically a smaller t, right? Like I basically get a smaller t here. And again, if I compare these two shapes, they're not symmetrical. There's nothing I can do to these two parts to make it equal to each other, which means option B here is wrong. Wrong. Let's look at option C. C here means if I cut the shape into like a diagonal, ooh, it's gonna be hard to draw. I'm gonna get something like this. So let's try to see if I can draw this. I get something like that, and I get, sorry, and then I get something here. I still get a thing here. Okay, that's the best I can do for that. And then I get my other shape would be kind of like this. And yeah, just like that. Again, these two shapes are definitely not the same, right? Like they're definitely not the same. I have this kind of this part here is not reflected. Does not contain it on the second part. This here is also incorrect. And if you actually do the same thing with D here, it's also incorrect here, right? If I split it up, I get kind of this exact same shape. I get this shape here and this shape here, but those two shapes are reflected. But either way, they both cannot be reflected to show a reflectional symmetry, which means A here is my only correct answer here because these two shapes are the same. So this here A is correct. We're given the given the letter T. It's like the figure here, line of reflectional symmetry of a geometric figure, line that shows which geometric figure, when reflected, remains the original figure, right? It remains the same. So these two figures are equal to each other. So A here, when reflected along the central line, the shape of the figure does not change. That's good. D is false here. Does not show line of symmetry as the bottom U shape will move upward on reflection. That's good. C and D are false. You get like a shape different from the original T. You get this here, which is really weird, and you get this here, which is really weird. So C and D are both false here. So this here is a great solution and analysis. Solution is correct. And finally, question 10 here. So let's look at question 10. Oh, it's finally an algebra question. I don't think I did algebra today. I think it's all geometry today, which is odd. But it says here a number divided by 40 has a quotient of 16. What is the number? So number divided by 40 has a quotient of 16. What is a number? So again, what we have to do with this problem is I'm giving words, right? I'm giving a number is divided by 40, right? When we talk about number, I'm going to say let x be the number, right? So that's going to be my first statement here. So let x be the number. So this entire here equals x, right? And I can say that is divided by 40, right? So I can say x divided by 40. So I'm writing a mathematical expression based on the word stuff they give us, right? So x divided by 40, or x over 40, has a quotient of 16. So when we talk about quotient, it means that the answer is 16 when we divide something together. When we divide a dividend and a divisor together, we get a quotient, right? So this here, this quotient just means that it would equal 16, right? Equals 16. And again, it says, what is the number, right? So we have this algebraic expression, or sorry, equation in this case. X divided by 40 equals 16. All we have to do is we have to solve for x, right? So again, we have x divided by 40. I want to do the opposite operation. So opposite of division is multiplication, right? So I have here, I'm going to multiply both sides by 40, right? So over 40, I'm going to multiply this side by 40 and multiply this side by 40. As you can see, the division by 40 and the multiplication here, these two guys cancel out, which means I have x here, x by itself equals 16 times 40. I'm taking my calculator for a sec. 16 times 40 here would equal 640. So this here is my answer Oh, I forgot a remainder with a quotient of 6. Oh my gosh, not quotient of 16. Sorry, I copied the question wrong. This here is all incorrect. My bad. Has a quotient of 6. Okay. And a remainder of 16. Okay, quotient of 6 and remainder of 16. Okay, so that changes our algebraic expression, obviously. So we have x, and we still have x divided by 40. Has a quotient of 6, right? 6 here, quotient of 6, and a remainder of 16, right? A remainder of 16. So 6 divided by 16 and 40, right? So we have to say that this algebraic expression would equal x over 40 equals 6 and 16ths over 40, right? 6 is 16ths, 6 times 16th over 40 here. So this here, again, this here is my my algebraic expression, the exact same thing. And what I can do is I can then do the exact same thing. I can multiply both sides by 40. So x, I have x here. I have to multiply by both sides by 40 equals 6 over 16th over 40 times 40 here. X cancels out, right? These two can't cancel out. And what I'm left here with, if I didn't want to use my my calculator, I can actually what I can do is I can change this into an improper fraction, right? So in order for me to do that, let me do some side work here. I have to do 6 times 40. 6 times the denominator is 240 plus the numerator. So 6 times 40 is 240 plus the numerator plus 16 is 256 over 40. So this here is 256 over 40 over 40. And then I'm still multiplying it by 40, right? And then I have x equals the 40, again cancels out, and I'm left with 256 is my final answer for this problem. So sorry for that. I misread the question. I didn't even know there was a remainder in the question, but I did. So there we go. Algebraically, this is x equals 256. So exact same thing. They did answer is 256, which is good. If a number divided by 40 has a quotient of 6 with a remainder of 14, that means that 40 goes into a number 6 times and still has 16 left over. So that's the definition of a remainder. We can call the number x. So and say x over 40 equals 6 and 16th over 40. So that's what I did here and solve for x. And then they did 16 over 40 equals 256 over 40, which is good. And then they simply just cancel out and x equals 256. Great answer. Great solution and analysis. So out here brings us to our end of our video. Again, we did 10 problems today. This is for grade 9 in grade 9 algebra, and grade 9 and a little bit of grade 10, but I think it was mostly just grade 9 algebra for today. If you're tuning in from the US, what we did was we covered many geometric problems, and we also covered some pre-algebra problems and algebra 1 questions. So again, we did 10 problems of this. If you were watching, again, thank you for watching. I hope you learned. I hope you got some learning done throughout this journey of this short journey of an hour of just answering problems together. And yeah, stay tuned for the next stream, which is going to happen at 12 p.m. Eastern. What I'm going to do is I'm going to look at harder problems. So harder problems in Algebra 2 and also in pre-calculus. So stay tuned for that. Again, thank you for watching. Have a great day. And as always, stay safe as well. Thanks, guys.